are done by using water. So we all know that water is much essential for our day-to-day life. So here, why I have chosen this place is, today's topic, you are going to see about the hardness of water. So what is hard water and what is soft water? See, in this modern world, we are seeing water lacking in many areas. So water scarcity arises. So wherever we are getting water that can be used in a useful way by treating or making it into a soft water. So suppose if we are getting hard water from the ground, that is taken and it should be converted into soft water and it is used for the drinking purpose. So we all know that naturally the soft water comes from rain. So that underground water what we are getting is hard. So how to find out the hardness of water? So the hardness of water that can be formed by using soap. So if you take soft water as well as hard water and making soap to dissolve into that, the hard water will not be lathered in the soap. And if you take soft water produces more lather in the water with soap. So we can identify like this. So what is the main reason behind the hardness of water and what we are doing in the water treatment plant? So the hardness of water is mainly due to the presence of calcium and magnesium salts. So calcium and magnesium salts along with so many ions which will be present in water, that should be responsible for the hardness of water here. So in which form they will be? Magnesium and calcium will be in the form of carbonates, chlorides and bicarbonates. So based on the ions, whatever it is present there, we can classify the hardness of water into two types. What are the hardness? One is the temporary hardness, the other one is permanent hardness. So what is temporary? We can make it as a soft water. The temporary hard water can be converted into soft water here, and that should be used for our household purposes and also for drinking purposes. And what is the main essential thing in our temporary hard water is the bicarbonates of calcium and magnesium. So here the bicarbonates that can be made into the precipitate by boiling method and also by clots method. Let us see those processes in detail. The temporary hardness. So what is temporary hardness? It is because of the presence of the bicarbonate present in water. Okay. So the bicarbonate present in water that should be treated by boiling. So we can remove it by making it as a precipitate carbonate. So how come it should be made? For this we can use two methods. One is boiling, the other one is clots method. So the first method I can tell now. So by using the boilers like this, the hot water is boiled. So what will happen when we boil the magnesium bicarbonate and calcium bicarbonate? That should be made into the precipitate of the carbonate. So that is, the bicarbonate is converted into carbonates there. So calcium bicarbonate, if we take, that should be made or converted into calcium carbonate. So the calcium carbonate is insoluble, so it will settle down at the bottom. Same way, if magnesium bicarbonate is there, when we boil that, it should be converted into magnesium carbonate, so it settles at the bottom. By filtration, we can remove all the precipitates so that the water should be free from magnesium and calcium bicarbonate. That water we can use for our drinking purpose. So the first method used to remove the temporary hardness is heating or boiling. So by boiling, the insoluble, that is the soluble bicarbonates are converted into insoluble
Hardness of water. In this module, you will learn about temporary and permanent hardness of water. If soap does not give good lather in water, the water is said to be hard. Now, what makes water hard? Well, calcium and magnesium ions present in water make it hard. Soaps contain sodium salts of higher fatty acids that serve to form lather. However, calcium and magnesium ions present in hard water react with these salts and form the corresponding calcium and magnesium salts. The resulting calcium and magnesium salts are not soluble in water. They remain on the surface of water as precipitates, commonly called scum, thus resulting in little lather. Calcium and magnesium ions in hard water are present as the soluble salts of calcium and magnesium, which may be their bicarbonates or chlorides or sulfates. When only bicarbonates of calcium and magnesium are present in water, the hardness of water is said to be temporary. Hardness of water caused by bicarbonates of calcium and magnesium is said to be temporary, as it can be easily removed by simply boiling the water. When temporary hard water is boiled strongly, calcium bicarbonate changes to calcium carbonate, water, and carbon dioxide. At the same time, magnesium bicarbonate changes to magnesium hydroxide and carbon dioxide. The resulting carbon dioxide escapes to the surroundings. On the other hand, the resulting salts, which are calcium carbonate and magnesium hydroxide, do not dissolve in water and thus form precipitates. The precipitates are removed by filtration, and this rids the water of calcium and magnesium ions. In other words, the water no longer remains hard.
Now, the second method we are going to use is Clark's method. So for Clark's method also we will be using containers like this. In the container we have to take the water, that is hard water. With that hard water we have to add a calculated amount of lime, that is calcium hydroxide. So the bicarbonates present in the hard water that can be converted into the insoluble carbonates. Okay, so when we add calcium hydroxide lime with the hard water and the process goes on, the lime started reacting with the hard water. The calcium bicarbonate and magnesium bicarbonate present in hard water reacts with calcium hydroxide and settle down. Upon high filtration, we can remove this insoluble impurities. So the hard water is converted into soft water. We can use it for our drinking purpose and household purposes. How to find out this hardness of water? So we are saying it is hard water which contains bicarbonates of magnesium, calcium, all these things are present there like that we are telling, right? How we will be finding out this one? So for that we have to take water from the ground and it should be tested in the laboratory. So there they will be using the EDTA method. So when water is treated with EDTA, it will be forming a complex compound. We have to estimate the amount of complex compound by doing titrations. So after estimating the amount of hardness or the amount of hardness in water, accordingly we will be treating that water. We will be adapting boiling method or the Clark's method for purifying or removing the temporary hardness of water.
Another method to remove temporary hardness of water is Clark method. In Clark method, some amount of lime is added to hard water. Lime, which is chemically calcium hydroxide, reacts with calcium bicarbonate to form calcium carbonate and water. At the same time, lime also reacts with magnesium bicarbonate to form calcium carbonate, magnesium hydroxide and water. The resulting salts, calcium carbonate and magnesium hydroxide, as you already know, do not dissolve in water and thus form precipitates. and once the precipitates are removed by filtration, the water no longer remains hard.
The permanent hardness of water. So permanent hardness of water, it is because of the presence of calcium and magnesium ions in the form of chlorides and sulfides. So if it is in the form of bicarbonates, we can remove it very easily by heating. But if it is in the form of chlorides and sulfides, the removal process will take little time, or we can use and adapt different methods for removing the permanent hardness. So the first one is for removing the permanent hardness by the chloride and the sulfide salts of magnesium is by treating with washing soda. We all know that sodium carbonate is called as washing soda. We can use that, thereby we can remove the permanent hardness. Second one is ion exchange reactions we can do. So we have to exchange the cation or anion, thereby the coagulation. We have to add the cations or anions, thereby the precipitate or the solution containing the chlorides and sulfides must be getting precipitated. The third method here is we have to use ion exchange beds like zeolites. So what are zeolites? Zeolites are sodium aluminium silicates. So the main purpose of using silicates is, zeolites is, they will be acting as the bed and absorb the hardness producing ions. So here we are going to take a zeolite bed. Before going into this process, we can discuss about the adding of washing soda. So we have to take the hard water which contains the chlorides and the sulfides of magnesium, that should be treated with the sodium carbonate. So when we add sodium carbonate, the insoluble carbonate precipitate is obtained there. So this insoluble carbonate precipitate settled at the bottom, we can remove it by filtration. Then ion exchange. We have to add cationic electrolyte or anionic electrolyte. The third one is using zeolite beds. So zeolite nowadays we are using in most of the water treatment plants, very effective methods of removing the permanent hardness. So what we will be exactly doing there? So zeolite bed will be there. In that the hot water should be allowed to pass through. When it passes through the zeolite bed is made with caves and holes. In that holes, the ions will be present there. The insoluble ions are absorbed on the surface of the zeolite when it passes through the holes, and the water should be purified or it should be removed from the hardness. So here the metal ion combines with the zeolite atoms, and then it should be, the water should be free from the ions whatever it is making the hardness. Thereby we can remove the permanent hardness of water by using zeolite.
Let us now learn about the permanent hardness of water. You may have noticed a hard white coating inside the electric kettles, on showers, and even inside utensils in which water is boiled. This hard white coating results due to permanent hardness of water. The permanent hardness of water is caused due to the presence of chloride or sulfate salts of calcium and magnesium. The white coating seen on different surfaces is nothing but a deposit of these salts. Permanent hardness cannot be removed by merely boiling the hard water. It can be removed by certain chemical methods that include treating the hard water with washing soda and Calgon's method, ion exchange method, and synthetic resins method. Let us first learn how permanent hardness of water is removed by treating the water with washing soda. When washing soda, which is chemically sodium carbonate, is added to hard water, it combines with the chloride salts of calcium and magnesium present in the water to form their corresponding carbonate salts along with sodium chloride. At the same time, washing soda also combines with the sulfate salts of calcium and magnesium to form their corresponding carbonate salts, but this time along with sodium sulfate. The carbonate salts of calcium and magnesium do not dissolve in water and thus form a precipitate. The precipitate is removed by filtration that frees the water of calcium and magnesium ions, and once these ions are removed, the water no longer remains hard. Calgon's method uses calgon, which is the commercial name for sodium hexametaphosphate, to remove permanent hardness of water. When calgon is added to water, each of its molecules ionizes to give 2 sodium ions and 1 complex anion. The complex anion further loses 2 sodium ions and captures 1 calcium ion or 1 magnesium ion from the water in return. As a result, the calcium or magnesium ion of the water becomes a part of the complex ion and no more remains free. This way, the complex anions of calgon capture all calcium and magnesium ions of the water, thereby removing its hardness. The ion exchange method uses zeolite, also called permutate, to remove permanent hardness of water. Chemically, zeolite is sodium aluminium silicate and it is insoluble in water. When zeolite is added to hard water, an ion exchange process occurs between the two. During the process, zeolite loses sodium ions to the water in exchange for calcium and magnesium ions. This way, the water becomes free of calcium and magnesium ions and is left with only sodium ions, which do not make water hard. In other words, the hardness of water is removed. The synthetic resins method uses ion exchange resins to remove hardness of water. Ion exchange resins are of various types, but the ones used to remove permanent hardness are represented as RNA. These resins are water insoluble and work by exchanging ions when added to hard water. Such resins exchange their sodium ions with the calcium and magnesium ions of the hard water, thereby freeing it from calcium and magnesium ions. This way, the water no longer remains hard.
Heavy water. Heavy water, it is the oxide of heavy hydrogen. The formula for heavy water is D2O. So if we take heavy water where it is present, means it should be present in ordinary water. If we take 5,000 parts of ordinary water, 1 part of that is heavy water. And how will we prepare this heavy water? We can prepare heavy water by the electrolysis of normal water. But easily we cannot do electrolysis reaction with heavy water. So normal water, when it undergoes electrolysis, we will be getting heavy water as the product. So when we take heavy water into consideration, it is a colorless, odorless and tasteless liquid like that of ordinary water. And all the properties, physical properties are similar to that of our normal water, but there are some considerable differences in physical and chemical properties of heavy water. property of heavy water. So heavy water, the formula is D2O. So normal water, the reactions will be happening. The same reactions will happen with heavy water also. And when heavy water reacts with acids as well as bases. So with sodium hydroxide, it will be producing the base, and with hydrochloric acid, it should be given deuterated chloric acid. And here few exchange reactions can also be taken with this one heavy water. And with heavy water, we are making n number of chemical reactions that should be very much useful in our industries.
Exchange reactions of heavy water. Heavy water reacts with sodium hydroxide, hydrochloric acid, and ammonium chloride, where the hydrogen present in all these molecules are exchanged with the heavy hydrogen. These exchange reactions are useful in determining the number of ionic hydrogens present. When D2O is heated with hypophosphorus acid, only one hydrogen is exchanged. It indicates that it is a monobasic acid. The next reaction is it forms some deuterium compounds. So heavy water is used to produce deuterium compounds. When it reacts with aluminium carbide, calcium carbide, magnesium nitride, and calcium phosphide, the corresponding hydroxides are formed.
Uses of heavy water. The first important use of heavy water is it is widely used as the moderator in nuclear reactors. What is a moderator? Moderator means in nuclear reactions we will be using the fast moving electrons to break the heavy particles. So in that fast moving electrons, the energy should be lowered by using heavy water. So heavy water is used as the moderator in nuclear reactors. The second point here is it is commonly used as the trace element to study the mechanism of metabolic activities. So we know that in our body, so many metabolic activities are happening there. So all the metabolic activities the mechanism can be studied by using heavy water. And the third point here is it is used as the coolant in nuclear reactors. Because in nuclear reactors, large amount of heat should be produced that should be used to rotate the turbine there. So that heat should be heated or absorbed by the heavy water. If we use normal water, it should be evaporated at a faster rate. So this heavy water absorbs the heat energy from the nuclear reactor, and it should be used to produce nuclear energy or the electric energy. So in this session, we have studied about the hardness of water. Under hardness of water, the temporary hardness and permanent hardness, how to remove temporary as well as permanent hardness we have studied, and we have studied about the heavy water also. Hope all have understood the concept. Have a good day and thank you children.